There were a bunch of fasteners in this part and this part that were at the top level of the assembly, and so what I did is I did a crossing window and selected those fasteners and moved those into either this assembly or this assembly as appropriate, and then I continued on with these steps, which I'll demonstrate now. So I tried to fix the constraints that were in here, and as I've found almost universally, it's easier just to start over than it is to try to fix up somebody else's work. So I'm going to delete the two pistons, the hydraulic cylinders or gas pistons, and the two brackets that held that from going too far. I'm just going to delete those components out of the assembly. Yeah, so let me delete those. I'll put them back in, and I had multiple problems with this being a sub-assembly, so I'm going to promote those to the main assembly. So I will go to component, and I'll promote the first part, and I'll promote the second part. Okay, so I've got the two sides of the piano hinge in the main assembly. I can now delete this sub-assembly. And if I drag this, I see that I didn't lose any constraints, even though it told me that I might lose a constraint. And there's some other constraints though that I'm going to get rid of. So I have a limit constraint limiting how far that is going to go, and that's this angle constraint, which I've set at limits. And then there's a constraint going through the middle of the piano hinge, and then there's a constraint going flush to the end of it. The rest of these constraints from here on up, I'm going to delete those. I'm going to put those in myself. Alright, so now if I drag this hinge, we see that it moves away. And so there were several mates on here to constrain that, and it would be easier just to constrain that with an insert. So I'm going to go to insert constraint. And as I was working with this, at some point I had turned on this lock rotation, and that was a day or so ago, and it stayed on. So watch out for that if you ever turn on this lock rotation. So I'm going to insert the bottom of this hole to this hole. I'll apply that, and then I will get the bottom of this hole to the top of this hole. I'll apply that, and then I'll get the these two holes, whoops, and I'll apply that, and I'll get these two holes, and so that simplifies the list of constraints that were here. I'm going to drag this angle constraint down here to the bottom because that's the one that I'm really interested in. So I drag this, and I see that it opens and closes as expected. I'll go to the dynamic simulation. I'm expecting to see a single revolution joint, and so I do have that revolution joint. I'm going to delete, if I move this up here, I might need to decrease the number of calculations so that'll move faster. There are some jacks in here that were put in by the original person who designed this, so there's a jack here. I'm going to delete those two jacks. So I'll delete this, and I'll delete this one. Okay, I'm going to delete this 3D contact. We'll put it back in if we need it. And so I have then just the revolution joint. Let's reduce this to 100 calculations. That way I can, as I drag this thing, I can move it faster. So I can move it up, move it down. We'll put the limits on here in a few minutes. Alright, so I've got my first joint, my revolution joint. That's working as expected. So next I'm going to place the two brackets in here, and we'll have to be a little bit careful with that, because as far as dynamic simulation is concerned, we really only need one bracket to limit that travel, and so we'll have to be careful how we handle those such that it doesn't give us an over constrained condition. And so I'll go to place, and I need to find that brackets. I don't remember what the names of them were. I'll go to view large icons, and that'll show me the images of the part, so I don't have to know what the names are. Hopefully there aren't too many here that I can find it, and here it is. So I'll open that, and I'll put that into my assembly. Alright, then I'm going to insert that in up here. So I'll do constraint, and I'll do insert this hole onto this. Now there's no clearance in between there. This should be this nut loosened up a little bit to allow a little bit of clearance, but for what we're doing, it's going to be okay. So I'll say okay to that, and so now I'm expecting that to be converted to a revolution joint. So I'll go to environments, and I'll go to dynamic simulation, and it is converted to a revolution joint. If it hadn't been, I would go up to the grounded, I would find that constraint and right click to retain degree of freedom. So we'll then do the same thing on the other side. We'll just go back to assembly here, and so I'll control drag another copy of this part out, and now I've got to make some decisions about how I want to do this, because I don't want it to give me an over constrained condition. I think we'll be okay, so I'm going to do constrain, insert. I'll insert this circle onto this circle, and I'll apply that. And so if I look at my I have a revolution joint on both sides, but actually I'm going to connect those two together so that they move together. So I'll do constrain, and I'll do flush this face to this face. I'll say okay to that, and that removed one revolution constraint. I only needed one, but then I still have a constraint, a revolution constraint, so these two are treated together as though they are one part now. They move together, and so that will simplify things. Alright, then the original design had a tangent, if I recall correctly. Whoops, I went too far. I had a tangent in here between this face and this face. There's a couple of different ways we could do that. We could do a sliding cylinder on curve, or we could put, if there's a plane through the middle of this, we could do a point on plane, or there's a circle in here. We could do a 2D contact between this and this. Let's try that 2D contact. That way that'll limit the travel. So I need to get this down inside there first, and I might have some trouble doing that, but I'll try to do it manually. And so I've gotten it close now, and I need to move it just a little bit more, and I hope that I have it inside there without it interfering. I could turn off the visibility of this part. Let's just see if I'll be able to see with it in wireframe. So I'll go to wireframe. So I want that yellow circle inside this slot, so I don't quite have it yet. So I need to move that just a little bit, and hopefully the designer did allow some clearance in between here. And it looks like I got it perfect right on, but we'll see here where it's tangent. So we'll go ahead and try to do that 2D contact now. So I'll insert a joint, I'll do 2D contact, and I will select this face, but it could be the outer or the inner edge, so I need to select the inner edge. And then for the second selection, I will select, and I want to get that sketch circle that's down inside there. I went too far. If I can get that sketch circle, and then the Z should be pointing out on the circle and in on the slot. We'll say okay to that and see if it puts it in. Okay, so it looks like it put it in. Now I don't want any bounce on that or any friction, so I'll go to the properties of this and I will change the restitution to 0. I'll change the friction to 0, although the friction wouldn't really be 0. We can increase that later, but for now I don't want it calculating friction. When we selected that circle, we might have needed to invert this normal on the circle so that it treats it. Remember, it can be the outside of a fence or the inside of a fence. I think in this case it's working correctly. So I'll try to drag this now, and it might be really slow. It got up to where it was in contact, and then it gave me an error. And now sometimes if you drag that and it gives you that error, you have to temporarily suppress it so that you can get it back where it isn't giving you an error. So I come up here and so now dragging it with the mouse, it can't keep up with the calculations, where when we put it under motion, it shouldn't give us an error. It might give us an error at the end of the travel, but I'm not sure whether it will or not. But so now it's actually, let's see what it does. I don't know where it does when it closes. So the slot, the top of this slot doesn't hit there when it closes, so we'll have to put some other constraint on there to keep it from going too far down this way, and that should be fairly simple to do. Okay, let's see. Let me save this thing and we can go on to our next step. Alright, so next I need to bring in one of the gas actuators, and so I'll do place, and I'm actually going to do that as the two components rather than as a subassembly, although I think there are more than two components, because I think there's also this part. We can bring in the subassembly, and then we can promote the parts from the subassembly. And actually right now I'm on parts. Let's just put it on just assembly files. So I'll go into the subassemblies, and I'll need to see those parts. And so here's that. I'll move that into here, and then again, with the trouble we've had, I'm going to promote all of these parts up to the top level. May not be necessary, but I'm tired of fooling with this, so I'll just do component promote on each one of these in that subassembly. I don't know if I can do this. Let's try doing all of them at once. I don't know if we can. Okay, so now in this subassembly there are no parts left, so I'm just going to delete the subassembly. And then I'll bring this over, and I forget whether it was at this end was up here or whether this end was up here. So I'm going to go back to my original assembly and check that. That's one reason why you should always make a backup copy of your assembly so that you can go back to the original and check it.